Welcome to my channel, viewers. In this video we'll discuss about finding sum of an AP. How to find the summation of the terms of a given AP series. Say for example you are given this series 2, 4, 6, 8, 10, 12, right? So it's an example of arithmetic progression. Here first term is 2 and common difference is here 2, right? 4 minus 2 equal to 2, 6 minus 4 equal to 2, 8 minus 6 equal to 2. So here first term is 2 and common difference is also 2. Now let's write this series in reverse order. 12, 10, 8, 6, 4, 2. We earlier discussed one thing, that when you reverse the order of the arithmetic progression, again you will find it's a arithmetic progression. So if you reverse this series, again you will find this is an example of arithmetic progression. Here common difference is minus 2 here. First term is 12 and common difference d equal to minus 2. That means when you reverse an arithmetic progression, the common difference will be additive inverse of the earlier series. First series is 2, 4, 6, 8, 10, 12. Common difference is 2. And when you reverse this series, common difference is additive inverse of this minus 2 here. Now you see, if you find the sum of the respective positions, sum total will be the same. First term and first term total is 14. Second term plus second term, that is 14 again. Third term plus third term, 14, right? 14, 14, right? So if you find the sum total of the respective positions, means first term with first term, second term plus second term, third term plus third term, you will find that sums are same. Now let us come to the standard form of an arithmetic series. Say standard form is first term is a, second term is a plus d, third term is a plus twice d, fourth term is a plus thrice of d, and so on. And nth term is a plus n minus 1 into d. We are assuming that this series has n number of terms, right? So how do you find the sum of this series? Sum equal to first term plus second term plus third term plus fourth term plus nth term, a plus n minus 1 into d. So this is the sum total of this series arithmetic progression. Now let us write this in a reverse order. We earlier discussed that when you write an AP in a reverse order, again you will find an arithmetic progression, just like this. We will write this series in a reverse order. Again, this is an example of arithmetic progression. So if you write this series in a reverse order, again you will find a arithmetic progression. So in that case, first term will be a plus n minus 1 into d, right? Second term will be a plus, what is the term before this? N minus 2 into d, right? So this next term, third term will be a plus n minus 3 into d, right? Term before this, right? And so on. And what is the last term? Last term will be a, right? So let us find the sum of these two series. S plus s, you got twice s. Then first term plus first term here, like this, 2 plus 12, 14. So we'll find the first term plus first term, second term plus second term, third term plus third term, and so on. So a plus a twice a plus n minus 1 into d here again you get a plus a twice a plus n minus 2d plus d. So what is the sum of n minus 2d plus d, right? N minus 2d plus d. That means nd minus twice d plus d. That means nd minus d. That means n minus 1 into d. So you again got n minus 1 into d. Again you find the sum of this, a plus a twice a plus sum of these two, again you find n minus 1 into d, and so on. A plus a, last term plus last term, a plus a twice a plus n minus 1 into d. So just like this, first term plus first term 14, second term plus second term 14, third term plus third term 14. Same way we are adding the respective positions. So you see the total is same, twice a plus n minus 1 into d, twice a plus n minus 1 into d, twice a plus n minus 1 into d, and so on. Last term plus last term, twice a plus n minus 1 into d. This implies that twice is equal to twice a plus n minus 1 into d. How many times? N times. Why? This series has n number of terms, right? This series has n number of times. So we are adding respective positions. So how many twice a plus n minus 1 into d will be in this series? N times, right? Twice a plus n minus 1 into d, twice a plus n minus 1 into d, and so on up to n term. We'll got this sum n times. So this is the repetition of the same thing, twice a plus n minus 1 into d. So we are multiplying by n, just like this, 3 plus 3 plus 3 plus 3 plus dot 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 n times suppose. So you will write n multiplied by 3, right, or 3n. Similarly, same thing you are adding for n times, so we are multiplying by n. So this implies that s equal to twice a plus n minus 1 into d multiplied by n divided by 2, or more simply we can write it as n by 2 twice a plus n minus 1 into d. So s means sum of this AP series, right? So summation of an AP series is given by, we can write it as Sn. Sn means sum of n terms of the series, n by 2 into twice a plus n minus 1 into d. This is the sum total of an AP series. That means up to nth term. But you cannot find sum total of an infinite series. Say for example, 2 plus 4 plus 6 plus 8 plus dot dot dot. So say it is up to infinity. We cannot find this sum. We can find the sum when only we are given the last term of the series. Say for example, if you are given like 2 plus 4 plus 6 plus 8 plus up to suppose 1000, or say some fixed number is given at the last end, then only we can find the sum of this series. Otherwise we cannot find the sum of an infinite series, right? So up to nth term, the total sum of the series is Sn equal to n by 2 twice a plus n minus 1 into d. Now let us do some example here. Say for example, example 1, find the sum of the following EP. So this is question number 1. Suppose you are given, find the sum of this series. Say for example, 34 plus 32 plus 30 plus up to last term here. So we do not know what is n here, right? So first we will find the number of terms in this series. A equal to here 34, D. What is common difference here? 32 minus 34 equal to minus 2. You are given nth term, n equal to a plus n minus 1 into d. This implies that a plus n minus 1 into d equal to 10 here. A means 34, n minus 1 into d means minus 2 equal to 10. So this implies that 34 plus or n minus 1 into d minus 2, that means minus 2 equal to 10 minus 34, implies that n minus 1 into 2 equal to 24, n minus 1 equal to 12, so n equal to 13. That means there are 13 digits in this series. So we can find the sum of this series, Sn equal to n by 2 twice a plus n minus 1 into d, right? So for this series, Sn means S13, sum up to 13, sum of 13 numbers of this series. So we'll write it as 13 by 2 twice of a means 34, plus n minus 1 into d, n minus 1 into d means n means here 13 minus 1 into d means here minus 2. So let us solve this. 13 by 2, this is 68, and 13 minus 1, 12, multiplied by minus 2, minus 24. So this becomes 13 by 2 into 8 minus 4, 4, 6 minus 2, 4. So 13 into 11, 22, right? 13 into 22, 286. So this is the sum of this. 286 is the sum of this series, right? Let's do one more example here. Example 2, suppose. Minus 37, minus 33, minus 29 to 12 terms. We have to find the sum of this series up to 12 terms. So we have to find S12 here. Now what is A here? A means first term of the series is minus 37. Common difference D equal to second term minus first term. So this means minus 33 plus 37 equal to 4. Common difference is 4. D equal to 4. So we have to find sum of the series up to 12 terms. S12 equal to n by 2 twice a plus n minus 1 into d. So what is n here? 12 terms. 12 by 2 twice of a means minus 37 plus n minus 1 into d. 12 minus 1 into d means here 4. So 6 multiplied by minus 74, 12 minus 1, 11 multiplied by 4, that is 44. So this is 6 multiplied by 4 minus 4, 0, 7 minus 4, 3, that is minus 180. So sum of this series up to 12 term is minus 180. We'll do one more exercise here. Suppose example, suppose given that suppose A12 equal to 37, A12 equal to 37, D equal to 3. Find S12. What is S12? 12th term of the series is 37. Common difference is 3. Find S12. So we are given A12, not the first term, right? So what is A12? A12 equal to, you remember the nth term of the series. n equal to a plus n minus 1 into d. So an equal to a plus n minus 1 into d, a12 equal to a plus 12 minus 1 into d, right? So a plus 11d. Now we are given that a plus 11d equal to 37. So a plus 11d means 3 here equal to 37. A equal to 37 minus 33 equal to 4. Now you find S12. S12 equal to n by 2 into twice a plus n minus 1 into d, right? What is n here? 12 by 2. Twice of a means 4 plus n minus 1. 12 minus 1 into d means here, and d means 3. So it is 6 plus 6 multiplied by 8 plus 11 3 33. So it is 6 multiplied by 41 246. So up to 12 terms of this series, sum is 246. So thank you viewers for watching this video. I hope you understood the concepts of the sum of the AP series. We can find the sum of an AP series up to a given terms. We cannot find the sum of an infinite series, right? So we'll discuss similar exercise in the next video again. Keep in touch. Bye bye.